Hello fellow engineers. So today we'll be checking out some of the free beam analysis softwares out there and comparing them with manual analysis to see how accurate they are. So the first website we would check is Beam Guru. And how to use Beam Guru, you just need to specify the length of the beam, which is 13.2. Then you specify the units of measurement. I'm using the metric units, so that is meters and kilonewton. So then click on supports, then you add the supports. For the example we're working with, we have 4 simple supports. So on the left we have a support, click add. On the right we also have another support, and then at a distance of 4.43 meters we have another support, and then at a distance of 9 meters we have another support. So now we have developed the continuous beam with 3 spans and 4 supports. So now we just specify the loads. Our beam carries uniformly distributed loads of varying intensities on each span. So for our first span, span AB, the intensity of the load is 16.30. So at start position is 0, and at end position is 4.43. And the load magnitude, like we said, is 6.30, and it's coming downwards. Then for our span BC, the load starts from position 4.43 and the end position is at 9 meters, and the load magnitude is 32.95, and it's acting downwards. So for our span CD, the starting position is at 9 meters and the end position is at 13.2 meters. The intensity of the load is 17.2 and it's acting downwards. So we've sketched out our free body diagram with the loads, the supports, and the distances all specified correctly. Then at span BC, we have a point load. So we'll go back to loads, click on the point load, and the point load is at the position of 3.75 meters away from support B. So 3.75 plus 4.43, we have that the point load is at a position of 8.18 away from our reference point, which is point A. So we impute 8.18, and then the load magnitude of the point load is 60 kilonewtons, and it's acting downward. So we'll click on add, and then we can go to the calculation. So the free version of Beam Guru gives you the bending moment and the shear force diagram, but the only limitation is that it doesn't give you the numerical results. So it says the construction is calculated using the mathematical apparatus of the finite element method. To obtain numerical values of diagrams and support reactions, you must get an access code. So the free version does not give you the numerical values, but it shows clearly the shape of the shear force diagram and the bending moment diagram. So for this our example, this is the bending moment and the shear force diagram. This is the shear force diagram QY, and MX is our bending moment diagram. And it actually does look similar to what we have from manual calculations, where we have a shear force of a positive shear force at support A of 23.31, a negative shear force at support B of 48.82, and a positive shear force of 84.66, and also at support C, we have a negative shear force of 125.92 and a positive shear force of 51.05. And then at support D, we have a negative shear force of 21.19. So this looks similar to what we have from our manual calculations. It also shows us that the only downside with Beam Guru is that you do not get to see the numerical values, but you can see clearly the sketch and how the beam behaves. So over here, we know we need to, this is our point of maximum moment, so we need to provide maximum reinforcements over here, and over here we need to provide reinforcements to combat the hugging moment here and here. So moving on, the next software would come, the next website we'll be checking is Optimal Beam. Optimal Beam would give you the numerical values and also the sketch of the shear force and bending moment diagrams. So we just impute our length of 13.2. Then we select the support types, support location at 0.0, add. Another support is located at 4.43. Click on add. Add another support at 0.9. And then our final support at the end of the beam, which is at 13.2 meters. So all these dimensions were imputed from our reference point, which is point A, the distances from our reference point. So support B is at 4.43 meters away from support A. Support C is at 9 meters away from support A, while support D is 13.2 meters away from support A. So we move on to our applied loads. Select distributed. So for our first span, which is span AB, we have a uniformly distributed load of 16.3. So we would impute 16.3. Oh, sorry. At start location is 0. At end location is 4.43. The start load is 16.3 and the end load is also 16.3. So this is asking for start load and end load in case you have varying loads, where at the start of the span you have, for instance, 10 kilonewtons, and then at the end of the span you have maybe 20 kilonewtons. So you can use this optimal beam to specify your varying loads as well. But for this example, we have a uniformly distributed load. So at start, the load is 16.3, and at end, the load is 16.3 for our span AB, which is why we put our start location as 0 and our end location as 4.43. So then we'll click on add. Okay, it has been represented here. Then we'll go again, and then this time around for span BC, our start location is 4.43 and our end location is 9. Our start load is 32.95 and our end load is 32.95. Then we'll click on add. So for span CD, our start location is 9 and our end location is 13.2. Our start load is 17.2 and our end load is 17.2 as well. So we'll click on add. Okay, so now let's just add our point load, which is at a distance of 8.18. So the location is 8.18 away from support A, and the load is 60 kilonewtons. So we'll click on add, and then you can click run. The various loads and support conditions are gotten from this floor plan, where we've analyzed the load being transferred from the slabs to the beams, and these are the loads that we got. Beam 7 is the beam we're analyzing, while beam 13 is the point load. So over here is the shear force diagram, and the good thing with optimal beam is that it shows you the intensity of the shear force at every point. So over here we have a shear force of, at point A we have a shear force of 23.31. Let me see if I can zoom into this clearer. So over here we have a shear force of 22.04, and in our manual calculation we have a shear force of 23.31. Over here we have our negative shear force of 49.30, and from our manual calculations we have 48.82 as our negative shear force. Over here we have our maximum shear force of 84.20 at 4.3 meters away from support A, which is exactly at support B. And from our manual calculations we have our maximum shear force as 84.6. So there's a rough 0.46 difference in values. Right, so the good thing about optimalbeam.com is that it shows you the value of your shear force at each point. So here now I'm at 0.6 meters away from support A, which is somewhere within span BC, and you can see the shear force at that point is 33.30, and here we can easily tell the point where our maximum moment occurs, because this is the point where the shear force is 0. We can easily trace it out to the point where the shear force is 0, and we can see that occurs roughly at 6.97 meters away from support A. So that's roughly 7 meters away from support A. That's where we would have our maximum bending moment. We can also see that at point 13.2, which is at the end of our beam, we have a negative shear force of 20.19, and from our manual calculations we have a negative shear force of 21.19. So over here we have a 1.0 difference. So the optimal beam is fairly correct. The differences between the manual calculation and the values given to us by the website are very, very close. So the bending moment diagram for optimal beam, you need to take note that the top is represented as positive while the bottom is represented as negative. So for those of us in countries where the hugging moment is represented as negative and is at the top of our reference line, of our 0 line, and our sagging moment is at the bottom of our 0 line, you should just take note of that, because here we have positive 49.14 and it's above our 0 line, and here we have negative 66.91. So this says that our maximum negative moment, our maximum hugging moment occurs at the point 9 meters away from our support A, and 9 meters away from support A is exactly at support C. So we have a negative moment of 66.91, and from our manual calculations we have a negative moment of 62.83. So there's roughly a 4.0 difference in values, right? And our maximum positive moment is 49.14, and it occurs at the point 7 meters, or to be 6.98 to be exact, away from support A, and the value is 49.14. And from our manual calculations, we have that our maximum positive moment is 52.24. So for this example, we can see that the softwares, the websites are giving us a very similar representation from what we get from our manual calculations. Beam Guru unfortunately does not give us numerical values on the free version. Meanwhile, optimalbeam.com gives us the numerical values, but you only get roughly about 5 trials before the free trial expires, and then you would have to subscribe. But for Beam Guru, you can continue to use their free trial for as many examples as you want to try, but to get the numerical values, you have to subscribe to the website. If you have any question, you can reach out to me on Telegram or on WhatsApp.